All right, in this particular video, we're going to kind of go over a little activity that we did. It was called Will It Hit the Hoop? And right now it says create the line of best fit. Whenever you're creating a line of best fit, you're trying to get that line that goes through many points as you possibly can. So that's what it was supposed to happen. All right, and that's what I wanted you to do. But you'll notice in this basketball video, this looks like the basketball goes up forever. So if I was going to say, like, what would happen, what does the line say will happen to the basketball? It will go up forever. All right? Okay. Now, understand, in a quadratic, it's not going to go up. In a quadratic, we have what's called a parabola. Now, look at the orange. That's called a parabola. And the highest point's called the vertex. So right about here is going to be the vertex. So what you were supposed to do is watch the video and ask yourself, do you think it goes in or not? So if this was the vertex, would it go in? So I'm just going to say, yeah, we'll go in. We'll go in. Okay. And then we watch the video and ask, will that go in? If that traced, would it go in? That might hit the backboard and go in, but I don't know. I'm just going to say out. Okay. All right. Let me just check this one. And so you keep doing this over and over and over again. So that's what we're going to be covering. So the students have been working on this. All right. So what I'm going to do is I am going to take a look at our snapshots. Okay. Or sorry, summary. All right. And we're going to take a look at what people got. So if you would, take a look at this with me, all right? So it looks like everybody, I've put it anonymous on the students, so no student will be called out here, but everybody did a good job of line of best fit, okay? So looks like people are saying it goes up forever. I like it. Okay. There's the parabola. So right here it says 11 students thought it would go in, and 1 student thought it would go out. Here, 8 in, 5 students out. And so we're going to go over here. We're just going to take a look at our final results. Okay. All right. Notice over here, it looks like 12 students said it wasn't going to make it because they had an opportunity to drag. It's kind of cool. You had the opportunity to drag the points and trace the parabola, and so they could clearly see that that would totally be out. So let's take a look at our results at the very, 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 very end. Oh, here we go. Here's the results. So if you would take a look at this, do you guys see these gray results, guys? The gray results are the overall class results. Whatever the green dot is, that's your personal score. No matter what, can you guys see how this gray version was a little bit higher than this one? What does that mean? That means when you had the opportunity, okay, when you had the opportunity to use the what? To use the tool, what happened to your guesses? When you had the opportunity to use the prediction tool, your guesses got better overall, okay? So what I'd like you guys to do right now is I'd like you guys to get your journals out because we're going to be talking about this equation right here. So get your journals out, and I would like you to type into Desmos right now, y equals x squared. Y equals x squared right there. So if you would please get your journals out, we're going to title it Quadratic Function, and I want you guys to put y equals x squared into Desmos. So here we go. In your journals, title it. Put it in blue. Quadratic function. So title it the quadratic function. Now what I'm going to do right here is I'm going to make a nice, neat little x-axis and y-axis. So right here, I want you to make your x-axis, make your y-axis as best as you can. There we go. Right there. All right. All right, so right now what I'd like you to do is in your journal, title it y equals x squared, and label that as your parent function. Today we're going to be talking about the features of all quadratic functions. And by the way, it's referred to not as a line, it's totally a curve. We call that curve a parabola. All right, so we're going to be dealing with what's called parabolas. We're going to make a little table. So make a little table right here, right next to it. Okay. We'll have our x's and we'll have our y's. And if you would please start with -2, then -1, then 0, then 1, then 2. Now, if we look at our table right over here, all right, now how do you get to a table on Desmos? You always hit the little gear button, right, gear button, and go to where it says convert to table, and you can clearly see the points that are on the table right there. What I'd like you to do is I want you to transfer these points over to your page. Okay, just transfer them right over to your page. So it's kind of easy if you think about it. What's -2 times -2? That's +4. And what's -1 times -1? That's a +1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. Then I simply want you to graph them over here. Remember, this is your x-axis. This is your y-axis. Let's go and start with 0, 0. And we'll just plot a 1, 1, a 2, and a 4, a -1, +1, and a -2, and a +4. And then do your best to make it as nice and neat as possible. Remember, this is in your journal, so you want to have a good representation of your parent function for all parabolas. So there we go. I know yours should look better than mine, all right? But you got that U-looking shape, okay? And that's your parabola. All right, so we're going to be talking about different points. So this is the most important point in this particular parabola, because this represents a lot of stuff. So what I'd like you guys to do is that is at 0, 0. Okay, that's at 0, 0. Now, we call that point a lot of things in the parent function. This point represents the vertex, because that's where it bottoms out. Okay, that's the vertex. Now, this particular vertex is referred to as a minimum because it's its lowest point. But this 0, 0 is also what's called the x-intercept of the graph. Why is it called the x-intercept? Because that's where it hits the x-axis. But it also happens to be the y-intercept of the graph. Now, there are other names for x-intercepts in a parabola. Okay, those other names are called zeros. Okay, you could call it a 0. You could call it a solution. And you could also call it a root. So what I want you guys to understand, anytime I say x-intercept, another word for x-intercept is 0, solution, or root when you're dealing with quadratics. All right, so those are very important. Does anybody see a line that splits the parabola perfectly in half? Like if you said, anybody see a line that splits this guy perfectly in half? What'd you guys say? If you had to make a choice. The y, yeah, you're right. The y axis splits it perfectly in half. Now, in this particular parabola, we call the y-axis the axis of symmetry. So the axis of symmetry splits this parabola perfectly down the middle. Now, the equation for this axis of symmetry in this particular graph is x equals 0. If you don't believe me, that's okay. I'm just going to watch. I'm going to type in x equals 0, and I want you to see how it graphs it. Ready? X equals what? 0. Do you see how it splits that right down the middle? And what do we call that x equals 0? We call it the what? The axis of symmetry. All right. So this is a parent function. Now, we're going to do one more really labeled graph, because right now, would you guys agree 0, 0 is pretty important in this one particular graph? What we're going to do is we're going to make another graph. So I want you guys to make, oh my gosh, one more graph. Yes, make one more graph. But this is not going to be the parent function. This is just going to be a parabola that has a heck of a lot more in it than the parent function. All right, so do your best. Make a nice x-axis and y-axis. And it's going to be very important that this is going to be kind of the map that you're going to use for all of your parabolas, kind of like a key. Like when you're drawing a map and it's got a key, it labels all the stuff. So could you guys please make y equals x squared minus 2x minus 3. We're still going to make a table. We're going to make a table. Now this table is going to be a little bit bigger, okay? Make it a little bit longer. We're still going to have an x. We're still going to have a y. We're still going to start with -2 on this one. We're going to go to -1. We're going to go to 0. We're going to go to 1. We're going to go to 2. We're going to go to 3. And I think we're even going to go all the way to 4. So we're going to go from -2 all the way to +4. Carefully call this your x-axis and y-axis. Now I'm going to pause the video to give my students a chance to catch up. If you would please, right above this, we're going to write what's called standard form. Now you're used to standard form in a linear equation, but we're going to write standard form of a quadratic equation. So if you would please put y equals ax squared plus bx plus c. Y equals ax squared. It's all lowercase. Ax squared plus bx plus c. Now, the beautiful thing about standard form is it reveals something every single time. And that c value, if you would label it, that will always be your y-intercept. Okay? That'll always be your y-intercept. Your y-intercept will always be 0, whatever c is. So honestly, I can already plot a point without doing any math in my head. Okay? So right now, what would be our y-intercept in this particular graph without doing any work? What's our c value? -3. Let's just put a point right here. Just trust me. Put a point right there. There's your y-intercept. Okay? Now, if I said in this particular graph, what is our a value equal to? What is our b value equal to? We already know our c value is equal to what? -3. What do you think our b value is equal to? -2. And what's our a value? Just a 1. Now, if you know, even though you can't see it, what's in front of that x squared? A 1. So that's called that my a value is a 1. Very good. Okay. Now, what I'd like us to do now is I would like us to take a look at our graph in Desmos, and we're going to make a table. So type this carefully into Desmos. It won't take long. All right, I'm going to clear this out. I'm going to go back to this right here. I have x squared, and I have what? -2x minus 3. There we go. And make a table. There we go. Make a table. And then you can add points. Check this out. You can add a 3. You can add a 4. Just like that. So I'm going to minimize that. There we go. So do you guys see these points right here? I'm going to take a screenshot of this. See those ordered pairs? I want you to write those ordered pairs down in your journal. So we were at a 5. Then we were at a what? What were we at? 0. Then a what? -3. Then -4. Then we were at -3, 0, and then finally at a 5. If you look over that's where I was getting those ordered pairs. So let's go ahead and plot these points, and we'll take a look at it. All right, here we go. I got -2 and +1, 2, 3, 4, 5 right there. I've got -1 and a 0. Okay. I've got 0 and a -3. We already plotted that. I've got 1 and a -4 right here. I've got 2 and a -3 right here. I've got 3 and a 0 right here. And I've got 4 and a 5 right here. So I carefully chose this function to be in your journal because it's going to give you a really good opportunity to be able to identify the key features of a quadratic function. You want to be able to identify those key features. It's a good graph. It's a good graph to use to teach students about key features. Now, One of my key features is going to be in green right here. I'm going to highlight that big time in green. One of my key features is going to be this orange. If you can, I don't know if you can see it there, but that's in orange. Okay. Another key feature we already know about is red right here. We already know about that key feature. We talked about that. Okay. And you're going to draw in one more key feature, except I'm going to make it a dotted line and not a solid line. This is a very important key feature in your graph. I'm going to put it right there. We've talked about it before, but we're going to talk about it again. And now I'm going to go ahead and pause the video to give students an opportunity to graph these key features on their paper. All right, so the first thing we're going to talk about, all right, the very first thing we're going to talk about is we're going to talk about this point right there. That's a very important point in the graph. Anybody know what that point right there is called? Starts with the V. That's the vertex. Very good. That's the vertex. Now that vertex is at a 1, -4. 1, -4. Now that is referred to as the minimum, which means the lowest point of the graph. All right. This point right here, we should know what that point is. What's that point right there? That's the y-intercept. Very good. That's the y-intercept, and that point is at a what? 0, -3. Does anybody remember all the different words for, I'm going to put this right here. Now this is at a 3, 0, and this is at a -1, 0. So what do we call those points? One of the words we called them was, we could say they are what? X-intercepts. So we could call those the x-intercepts. What's another vocabulary word we could use to refer to x-intercepts? I heard somebody say, I think somebody said solutions. Correct. Anything else? Roots. Very good. We call those roots. What else? Zeros. Very good. Zeros. So these are all interchangeable. So what I want you guys to understand, these right here all mean the exact same thing. So if I say x-intercept, that's the same as solution, the same as root, same as 0. Now, check this out. This can be kind of cool. How can you identify the vertex in a table? Not in the graph, but in a table. Would you guys agree this was our vertex right here in our table? I'm going to put, that's our vertex right here in the table. There's a cool pattern. There's a cool pattern. Look at right here and right here. How could you identify that this point, even if we didn't have the graph, how could you identify that this would be the vertex? How would you describe that? Go ahead. Exactly. On each side, it's like a mirror image, right? You guys know what symmetry is, where everything has like a perfectly, it's like a mirror image across. So that's how you can identify a vertex in a table without even looking at the picture. All right? How can we identify the zeros in our table? Check this out. What do those 2 points have in common? What do they have? Would you guys agree the y value is a 0 right there, and a y value is a 0 right there? So that's how you can identify where the zeros are in a table. So I've seen lots of tests, guys, where they don't give you the graph, they give you a table, and you have to identify what's the y-intercept. Ooh, how can you identify the y-intercept or a 0? Check this out. Remember, what's the y-intercept? The y-intercept is right there, because when your x value is a 0, that's always your y-intercept. So can you please label, not just your graph, can you please label your table? You got to know what's in your table and what's in your graph. Okay? Last but not least, one more. Does anybody remember what that line, that vertical line, we're going to call it x equals 1, what that line is called? It splits it right down the middle. It's called the axis of something. Very good. It's the axis of symmetry. All right? Now, understand there's a beautiful equation. Now, I'm not expecting you to know how to use it yet, but I want you to write it in your journal. There is an equation for the axis of symmetry. The equation is -b over 2a. So guys, this will not be on your formula chart at the end of the year. I use this so many times to help me find my axis of symmetry. It's negative b over 2a, and I'm going to show you how to use it right now. Axis of symmetry always passes through the vertex. That's a phrase I want you guys to write down. All right, you can put a big old box around it if you want. Okay, the axis of symmetry always passes through the vertex. All right, let's check this out. What is our b value over here? What's our b value? Negative 2. So I'm going to put negative, open parentheses, negative 2 over 2 times my a value. What's my a value? Right there, 1. So here's what I get. A negative times a negative is a positive. I get 2 over 2, which is equal to a 1. What did I say the equation for the axis symmetry was? X equals a 1. So that's how you could use, without looking at the graph, that's how you could find your axis of symmetry. So this right here, this is a formula that I want you guys to write down. Now once again, I'm going to go pause the video to make sure students know what to write down in their journals. All right, in conclusion, what I would like you to do is I would like you guys to write down the key features that you need to be able to identify, okay? So in your journal, what I'd like you to do is just write the words key features. I'm going to put 1, 2, 3, 4. What's one of the key features that we should be able to identify in a parabola? The vertex. That's one of the key features, okay? So put vertex. What's another key feature? The y-intercept. Good. The y, let me spell that correctly. Y-intercept. And I'm going to put x. I'm going to put intercept. Ready? Except I'm going to put parentheses s. Because sometimes, listen, sometimes, how many x-intercepts did we have right here? No, right there. How many? 1, but how many did we have over here? 2. So sometimes you might have 1, sometimes you might have 2, sometimes you might have none. So could you guys put right here, you might have 0, 1, or 2 x-intercepts. How could you have no x-intercepts? Like if your graph, don't do it, opened up or opened down and didn't touch the x-axis, all right? And last but not least, what's another thing we need to be able to identify? Axis of symmetry. All right, and what was the equation again? X equals negative b over 2a. That's the equation for the axis of symmetry. So get those key features down. All right? Now, as we're doing this, I want you guys to understand that in a parabola, all right, in standard form is y equals, you already have this down, so you don't have to write this down again, okay? But I want you to understand what the a value does. So if the a value is greater than 0, which means the a value is positive, the graph will open up. But if the a value, which is this number right here, is less than 0, which means if it's less than 0, it becomes negative, the graph's going to open down. So what would happen if we have a graph that looks like this, where it opens down? What do you think this point is still called right there? If it opens down. What did we call it over here? We called it a vertex, right? The only thing that's different, it's still a vertex. Okay? It's still a vertex. The only thing that's different, it's no longer a minimum. It's considered to be a maximum. And that's the last thing we're going to talk about today. All right? When I say talk about, it means you still need to be listening, but I want you guys to understand what happens when you make the a value negative. So look at Desmos right now. Look at Desmos. Does everybody see right here our equation? Look what happens when I make it a negative. what happened to that graph? It opened from up to what? Down. Now, interestingly enough, it has the same y-intercept, right? But how many solutions would this graph have? 0 solutions. So this graph would have what's called no solutions. Okay? So let me tell you guys the difference. Ready? How many solutions? We're going to do a quick little graph. Now, right now you should have everything in your journal. Just pay attention. See if you guys can figure out how many solutions. How many solutions? 0. How about this? How about how many solutions? 2. 2 solutions. One there, one there. All right? Now, when is it going to be one solution? Check this out. I'm going to make a graph that has one solution. Ready? X squared plus 4x plus 4. Where is its solution? Right there at what? -2, 0. And what is this point right here? What do we call that? The y-intercept. What would be the axis of symmetry? X equals -2. Because the axis of symmetry, what does the axis of symmetry always do? It passes through the what? The vertex. Okay? Now, all I want you guys to understand is Desmos. Check this out. Desmos. Let's look at our original equation that we typed in. Ready? Well, not original, but the second one. If I said x squared minus 2x minus 3. Here's the cool news about this. Check this out. When I click the graph, look at the points that automatically pop up on Desmos. What pops up? The zeros, the y-intercept, and the vertex. Every single time. What does that mean for you all before I let you go? What does that mean? Desmos is helpful, but what does it do? What does Desmos do? It gives you all the what? All the key features of that graph. All right, tomorrow we're going to start our assignments, but remember, please have this beautiful picture in your journal so you can identify the key features of a parabola.